Hi everyone, good afternoon, if it is afternoon, if not good morning or whatever. Okay, so UrhoSharp is it's an open source game engine. It's a managed binding to the Urho 3D game engine, which is a small and light yet very comprehensive game engine with a very clean API. So if you want game engine-like features or in your app, or if you want to write a game, it's an absolutely fantastic candidate for that. It's got a really, really clean C# API through the binding. There's full source code and has a lot of great features. So you might be wondering what a game engine gets you. Now, these are things that aren't just applicable to games. Any kind of simulation or visualization kinds of apps that need to load resources, react to input, do rendering, play sound, any kind of 3D content, a game engine is a great candidate for that. So it handles all of these things for you, like managing your scene, all of the 3D objects in that scene, how to render them onto the screen with various different rendering modes and capabilities, things like lighting and shadowing, all that kind of thing. It also handles various kinds of animation, whether simply scaling or fading, or even full skeletal animation if you have, say, human figures. It has a physics engine, so you can simulate physics, which a lot of games need, but may also be useful in any kind of visualization. For example, it's a great way to animate things. If you had a bar chart, you could have the bars just drop and bounce as they land using the physics engine. And lastly, it's a cross-platform. It runs on iOS, Android, Windows, Mac, UWP, and even HoloLens. We have some great HoloLens samples out there that show things like putting figures moving around the room that you're in into that space created by the HoloLens scanning. And that's super cool. I very much encourage you to check it out. If you don't have a HoloLens, I know they're a little pricey, but I'm sure in the future they'll be a lot more widely available, and it's super exciting. Okay, so I'm going to start by showing you just how easy it is to get started. Okay, so I'll be using VS. All of this works in Xamarin Studio on the Mac as well. So the first thing I do is go to Extensions and Updates and Online, and then I search for Urho. And you see here we have these two extensions. We have the Templates extension, which is a really quick way to get started, and we have the Assets Previewer, which is very cool. It visualizes things like models directly in VS. That's only supported in VS right now, not Xamarin Studio, but we'll be bringing that there in the future. So I have this installed already. I wanted to make sure that I wouldn't run into any network trouble or anything like that. So I'm just going to create a new project. And here we go. We have a blank UrhoSharp game. So I'm going to go ahead and create that. I don't have a Mac connected right now, so I'm going to just unload my iOS project. So that's really how quick and easy it is to create a project. And then when I build and run, it's not going to be terribly exciting, but it does work out of the box. So UrhoSharp is distributed as a NuGet containing a PCL. So you can see here the portable project, which contains the definition of the game. I'll be explaining how some of these work a little later.
And hey, Mikayla, can you zoom in your font a little bit too on Visual Studio so we can see that a little bit better?
Oh yeah, sure. There we go.
And also, we have a question while we're doing that. Does it run on Windows 8.1 or Windows Phone 8.1? I should say.
I believe not. At least we don't ship a component for that. I'm pretty sure it could be ported, but that's not something that we're currently planning to do. So as well as Urho itself being open source, UrhoSharp is open source as well. So if there are platforms that you want to support that are not supported already, it is possible for you to do that. Okay, so here is a sample. It is, as you can see, a spinning cube with the Xamarin logo. And I'm going to, I have some slides which will explain all the bits and pieces that go into that. I'm just going to stop that for now. But yeah, so this is a subclass of the application class. Here's the code that sets up the scene. There's some basic use of input, subscribing to the escape key. That's not going to work so well on Android, but on desktop that's important. Showing some UI, and a scene with a box, and a model, and a material, and some lighting, and a camera, and a viewport, and some actions. And a lot of these are basic things that you need in your scene. You need a basic scene, you need an octree which divides it up so the renderer can inspect it in a performant way. Then here's the box, and the box is just a node. It doesn't have anything by itself. It represents some kind of thing in our scene. It could be a character, it could be a piece of terrain, a piece of furniture, a bar in a bar chart, a camera, a light, just any kind of thing that is in your scene. Even things that are more abstract, like a sound. A node by itself has no real behavior. It just has a position and a scale and a rotation. But what makes nodes really interesting is that they are containers for components, and components are where all the functionality comes from. So here you can create components by type. There's a large number of components available, but this is a mesh, a model, and then so then we load the actual model into that from a resource. Then we assign a material to that. So that's adding a node with a component to the scene. And later down here we create a light, set some properties on that. And also, of course, we need a camera so that we can actually see the scene. So the camera is also a node in the scene that exists in the space of the scene, and it's a node with direction. And whatever direction it's pointing at, and whatever scale that has, it's essentially like a real-world camera, but in your scene. And then finally, we set the viewport on the renderer, which tells the renderer to use the camera to render the scene onto the viewport, which is the actual surface. And then here we have the action system, which I'll cover a little later. But that's how we get this bouncing and rotating effect. You can do some very, very simple animations very, very easily. And because it's a PCL, the actual projects themselves are very simple. So this, for example, the Windows app version, if I set this as a start up and run that, you can see it launches very quickly, does exactly the same thing. And you saw the little bounce and rotate there, and you can see the light shining off of the surface. And then for some reason escape doesn't seem to be working. Okay, and just to demonstrate that this is actually working, I'm going to change the color of the light. And there we go. So that's what happens when you change the light to a very red light. And as you can see, that's how light behaves. Red light on blue surfaces are a very dark color. Okay, so back to the slides.
So, Mikayla,
yep.
Sorry to interrupt. So we actually have 2 questions here.
Yep.
I want to, before you go on. One was, it says, I saw both a NuGet package and something in the extensions and updates. What was required in the extensions and updates?
So the extensions and updates was the Urho templates extension. So it's right here. So that is actually just what added the file new project that created all of these projects for me. If you wanted to, you could have created those by yourself.
Okay, that makes sense.
Now these contain packages, which are the NuGet package, and if you wanted to, you could have just gone and added that to any project directly.
Great. Okay, so we have one more question. Do you see any use cases for using this for location-aware models?
Could you clarify what you mean by location-aware models?
So yeah, Ryan, if you want to clarify that a little bit, maybe we'll come back to that in just a minute. So just go ahead and give us a little bit more detail what you're looking for there, Ryan, and we'll get you an answer.
Okay, so as I showed in the sample app, the new project, the core of the app is really a subclass of the application class. That's the heart of your game. All you really need to do there is override start, and in start you will create your scene and load any nodes into that, set up your camera, your lights, all of that. There is actually a serialization system, so rather than creating these things in code, you could actually save your scene out to disk and load that from disk. And there is an Urho scene editor that you can use to edit those scenes. It's fairly basic, but it gets the job done. So the application class, which is subclass, that contains properties with instances of the engine subsystems, and the subsystems are what actually do all of the work. So the audio subsystem, for example, looks at all of the nodes in your scene, takes the audio components on those nodes, and then renders them relative to the camera into an actual audio stream and outputs it out the speaker or headphones or whatever. Likewise, the graphics subsystem takes all of the nodes with visual components like the meshes and terrains and so on. And together with the camera, it then uses the renderer subsystem to render those to screen. The input subsystem is how you get information about what keys are pressed. There are events, you can check state, like whether a key is down, and so on. There's a UI subsystem, which has a basic controls mechanism, handles things like text rendering, it has buttons, labels, all that. It's fairly simple, but the UI that games need, like in the 3D view itself, is usually fairly simple, and it does get the job done. It also has a styling mechanism, so you can make it look however you want. I'm not going to go into a super amount of detail in the ways that all these things work, because game engines are very complex things. This is more going to be a sort of high-level tour of what the various bits and pieces are, how they fit together, and where you need to look if you want to do specific kinds of things, and the kind of basic components you would need to put a very simple app together and understand what's in that file new project template. It is fairly easy to get to grips with. I did a game jam in March on a train, actually, 52 hours on a train, and I wrote a game in UrhoSharp, having never used it before. So, yeah, and it was a fully working game with sound and input and pretty graphics and gameplay and everything. So yeah, it's definitely possible to get up to speed fairly quickly. But I did have background in that I've used various different kinds of game engines before, so I knew what a lot of these concepts already were, which is why I'm more focusing on the core concepts here. Okay, so as I mentioned earlier, you have a scene, and the scene is really a container for all of the nodes in a scene. And you're typically in a game, a scene would represent a level. You might create another scene and swap it out when you want to load a new level. Scenes are where you would attach the more global kinds of things, like a skybox. There are also some fundamental components you need to have on your scene, like if you want to be able to render it, you need an octree, which subdivides space and allows the renderer to efficiently find nodes within that space. If you want to do physics, your scene will need a physics world component. The scene is actually a kind of node itself, but this is really like this isn't a multi-level hierarchy. You have a scene, and the scene contains nodes. Nodes don't contain further child nodes. Scenes contain components, nodes contain components, but that's all the structure there is. Though I have seen samples where people create things made up of multiple nodes, and then they place components in those nodes that know about the other nodes and interact with them. So you can still build very complex things. So if you want to create some kind of object in your world, like an enemy, for example, you're not going to subclass node. That's a common mistake that people make. Really, you just want to encapsulate any new behaviors you want for that thing into a subclass of component. So here in the diagram, for example, you can see I have a node which has an enemy AI component, and I've put that in purple because that doesn't actually exist. That would be something that I might create by subclassing component in this case. And that AI, that component would, whenever the scene was updated, it might look around, inspect other nodes in the scene, and based on what's going on in the scene, it might move its parent node around. And you can also see other things in this little scene here. The enemy has a static model, which is its mesh, enable it to actually be rendered as something you see. It has a rigid body, which is what the physics engine sees the node as. The physics world is going to find all of the physics components in your scene and run simulations to work out what they need to do, how they move, and so on, in reaction to bouncing off of each other or whatever they do. And then based on that, it's going to move their containing nodes around. And that also has a collision shape, which is essentially the shape that the physics engine sees. So the shape the physics engine sees isn't necessarily the shape that the renderer sees. And then over there we also have a terrain node, which is a terrain component which represents the ground. Those you can author as height maps. So simply a texture where the black to white level represents how high the ground is. And then a rigid body so that things will actually stop when they hit the ground. That gives it a physics surface. And then a collision shape, there's a helper that will actually create a physics shape from the terrain mesh automatically. So that's really just like a sample of the kinds of things you might do in your scene. You might also, for example, attach an audio sound node component to your enemy node so it can make sounds when it shoots you, and they come from the right space from the right place in the 3D world, because that sound will essentially be where the enemy is. So the pattern that tends to emerge is that you have factory methods. So you might have, for example, a create enemy method that takes a scene, and then based on that, it will do scene create child, give it a name, and then attach, set some properties on that node itself. In this case, it's a light, not an enemy, but the principle is the same. So here you might have, for example, this code might be inside a create light helper method, and would return. It doesn't even need to return the light node unless you need a reference to it later. And nodes also have a name and an ID. So when you inspect the scene, you can search it for particular kinds of nodes. So you might, for example, give all of your enemy nodes the name enemy, and then you can iterate over the scene and find all of those if you want to do something with them. So a very fundamental concept to games engines is the idea of a game loop. So on some update frequency, the game is going to be, it's essentially running a loop. And each loop, it updates the state of the world and then renders it. So it's going to go through all of the scene, all of the, so the engine has this loop. Every time it loops, it looks at the active scene, and then looks at all of the components on the nodes in that scene which have subscribed to the receive scene, which have set the receive scene updates property. And if they have set that, it then calls the onUpdate method. And that method is passed a float with the number of seconds until it was last called. typically that gets called every frame, which at 60 frames a second is going to be 16 milliseconds. But there might be various reasons that it might run a bit slower. It might stall. Maybe the garbage collector will run. You should be careful about not creating too much garbage because you don't want to trigger that. So that enables your update handler to know how long it was since it last happened. So if, for example, it's moving your node at a certain speed, you could then represent that speed in like distance per second. And the fact that you've been given the number of seconds since you were last updated, you could calculate the distance that you would have moved in that time, and then move the node by that amount. You can also access the application's time subsystem. There's a static property called application.current, which lets you get hold of the current application instance. So, for example, you can access the time subsystem, which keeps track of time, and the elapsed time property on that is the number of seconds since your app or game started running. There are also various events on the engine that you can subscribe to. There are various phases that happen at the beginning, like at the very beginning of the update, at the end of the update, when on the physics update step, on the rendering step. There's a whole sequence of steps that are called there, and if you have a need to subscribe to some of those, you can find those on the engine. Something that's really cool is that we set up a synchronization context automatically. This is one of the pieces of machinery behind C# async code, and it's how the async code finds the context to resume in. So if you have C# async code and you have some code that's running, for example, in an update handler, you might start an animation, and that animation might return a task that represents when that animation completes. You can await that, and you're not going to block the game loop. But because we have a synchronization context, it will resume in the game thread on the game loop when that amount of time, when that task is done. So this makes it really easy to describe, to write code that feels synchronous, where you're describing like how some node is behaving over time, and yet you're not blocking that game loop. You're not having to start separate threads and marshal them back. So in our samples, you'll see very heavy use of async code because it's really powerful. And of course, if you want your game to be interactive, you might not need this if you're just showing a bar graph, a 3D bar chart, for example, and you just want to make use of the rendering capabilities. But if you're writing an actual interactive game of some kind or a simulation where you want the user to be able to interact with it, you can use the input subsystem for that. Again, this is a property on the on your application. You can subscribe to various key events, for example, the key down event, and also at any point in your game code, you can inspect the current state. So you can inspect which keys are pressed down. You can inspect the various finger touches that are present on the screen at that point and where they are. So for example, you might write a global update handler that every frame it checks where all the touches are and puts something underneath each of those fingers to represent some kind of feedback for the user. On mobile, you may also want to add an on-screen joystick. This actually uses the user interface system, and there are resources that include a joystick. So that will be one of these things you see in games where it's a little pad on the bottom right of the screen that you can move around with your finger, and it's kind of like a simulated joystick on the surface of the game. So that functionality is built in. You do have to use about half a dozen lines of code to set it up, but you can find samples of that. It's very straightforward. So on your input handler, you are typically going to want to update the world state, and then the various components on the world will propagate changes around from there. Like, for example, if you have a shoot input, you may want, when you receive that input, you might create a projectile node in the scene and give that a speed and set up a collision event on that node, and then just let the world run. And at some point in the future, that node is going to get a collision event, and at that point you'll check what it hit and what happened to that. But essentially, you want to like push things and then let them go. Your world should be kind of like everything should be self-sufficient, reacting to each other, and the inputs just poke it and watch it do its thing. So one of the things that you will need a lot of is resources. These are going to be things like textures, models, sounds, materials, UI definitions, and there's a resource loader for that. Again, it's a property that you access on your application class, the resource subsystem. Typically, you put these in a data folder in your app. On Android, they're assets. On iOS, they're bundle resources, and so on. And Urho knows how to load those. So you refer to them by their path within that directory. So, so in this case, resourcecache.get model is going to load the box.mdl file in the data models directory. And it's not required to organize them like that, but it is a convention that you put your models in a model directory, your textures in a texture directory, and so on. If you want to organize them in other ways, you can. There are also some core number of resources built in, some basic materials and UI style and so on. And you can access those via the core data class has the IDs for those. Now, often in game engines, you have to compile your resources to specific formats so they can be loaded, because the game engine will only understand how to load specific kinds of things, or specific kinds of be more efficient than others. In the case of Urho, it does actually understand loading files like PNGs and JPEGs, which is really convenient at development time. But when you publish your app, you're probably going to want to compile those into more efficient formats that can be loaded more efficiently by the GPU on the device. So I won't get into that in detail right now, but it is something to be aware of. For the case of things like models, there is an asset importer tool that you can download that will convert a number of common model formats into Urho's own format. We're currently working on a mechanism to make this more automatic so that from the IDE you have an import and convert operation you can do there, but currently you do need to do this yourself.
So, Mikayla, we actually had a question. So what format of models are supported?
So the built-in format, it has its own .mdl file. There is an asset importer tool that you can download from the Urho site, which will convert most kinds of common model formats from various tools into that format with varying levels of fidelity. So in some cases, you may need to tweak those later. But you can import models from Blender, from Maya, and so on. I may be misremembering, but I haven't used it personally, but I believe there's a Blender plugin that allows you to use the Urho format directly if you do need to apply those tweaks. If anyone doesn't know what Blender is, it's an open source, free 3D modeling and rendering tool. It's a little tricky to get the hang of using it, but it's very powerful. Yeah. Okay. So one of the other core concepts that you need to know is materials. When you have models in your scene, the material is what's used to actually render that model to the screen. So you apply a material to the model, and the material is what handles essentially what the surface of that model looks like. And in Urho terminology, there's this additional concept called technique. Materials are a very broad concept. You'll find those all over the place. Techniques are kind of Urho specific, but these are XML files that define how the shaders plug into the various passes of the engine. Fortunately, you don't actually have to understand how the details of that work. There's a huge number of techniques that exist already in the core assets techniques class that has all of their IDs. So those shaders essentially take inputs like textures and colors and then use them to render the surface. So your material defines the textures and other inputs, and then refers to the technique. You can see in this example here. So materials you have to load with resource cache.get material, but they're actually defined as XML files. They're very simple. You just have the technique, which is the name of the technique ID, and then the various inputs for that. In this case, this is a diffuse shader, which pretty much just maps the texture directly onto the surface of the model. No fancy manipulations or mappings or blending or anything like that. It just puts the texture on the model. So in this case, this is putting this texture resource into the diffuse input of the diffuse technique. So you'll have to create those for all of the resources you need for all of the materials you need in your app or game. There is actually a convenience. If you set the color on the color or the alpha on a static mesh, that's actually a helper that applies a material to it that uses that color value to render it. So if you apply both the material and that color, they're not compatible. But if you simply want to have something like a red sphere or something, you can do that without having to deal with materials directly due to that helper. And you can also construct these in code if you want, but I advise against it. Yeah, and the built-in techniques, they're quite comprehensive. They have all sorts of different kinds of blending modes, and there's even physically based rendering techniques. The pipeline supports forward and deferred rendering and various combinations of them. It's very flexible and configurable. And so once you have your scene set up, you're going to want to make it do something. Now, of course, you can, in your update handlers, you can just move things around directly. Or if you want to do something more advanced, if you happen to have rigged models, there's a skeletal animation system, but I'm not going to go into that right now. But there's actually also this really cool composable animation system. It's not part of Urho itself. It's part of UrhoSharp, and it's inspired by Cocos. It essentially you just have this run actions async method on nodes. So you can just call the run actions async method and give it some number of actions. And you'll find these in the Urho.actions namespace. There's a huge number. They can do things like moving, fading, scaling. And so in this case, so run actions async is a params method. So it's going to first move the node, and then it will fade it out. And those will happen one after the other, and it returns a task so you can await it. So if you want to do simple animations, like for example, in my game that I made, I used this animation here for pickups. When you picked up a pickup, it would move upwards a little bit and then fade out. And then I awaited that and destroyed the node right after that. You can also, again, I won't go into this in super detail right now, but there are various ways to control the easing. You can run them in parallel, so you could combine these so that it both moves and fades at the same time. And you can also write your own. So if you wanted to animate properties that aren't available from the built-in actions, like on one of your custom components, for example, you could write an action to handle that. And yeah, as I showed you in the templates, you're typically going to use a PCL or shared project for the vast majority of your game. Your various head projects for iOS and Android and Windows and Mac and so on will pretty much just create an instance of your application class and to start. There are a couple of cases in Android, for example. You need a fair bit of boilerplate to hook up the events into Android, but you can pretty much just use that as is, created by the templates. I appear to have lost half of my sentence here, but For resources, I would recommend using a shared project or file linking. Something that I did for my game was that I defined a new item type, and all of my assets had that item type, and then I wrote MS build transforms that map them into the output directory on Windows or into bundle resource items on iOS, and to Android asset items on Android. So I could just maintain these in one place in my shared project. I also wrote a little T4 file that would, based on the files that existed, would generate a class with IDs for all of those, so I didn't just have to use magic strings to refer to the names. Now these are things that we are planning on integrating into UrhoSharp itself at some point. But if you'd like to use them in your own games, I can share my examples with you for that afterwards. Something that's super cool that you can do though is that rather than just letting the app set up a full screen context, you can embed it as a view into a custom surface of some kind. So we actually have an Urho.forms NuGet, which gives you a Xamarin Forms control, and so you can pass that forms control your application, and it uses custom renderers to embed the Urho view into that forms control. So you can have it, for example, just taking up a small part of the screen while you have forms UI elsewhere on the screen. And we have a really cool example of using that for a line of business style bar chart, which I'll show you in a moment. So I realize I'm running short of time, so I'm going to be very, very quick here. Yes.
And I've been saving some questions towards the end too, so we have quite a few questions to go through as well.
Okay, so this is the samples directory that you can download from GitHub. I'm just going to open this one up very quickly, the form sample, and run it. And this will be a sort of a bit of a recap of seeing what an actual Urho application looks like. Okay, so here we go. So we have our Urho. Okay, so this is a portable Xamarin Forms project, which is a Forms app, and it creates an Urho. Well, it creates a content page, and on that page it has a surface, and that surface is what actually does all the work. So this is just forms code here. So where's the actual Urho code? Well, it's actually in this charts. Charts is an implementation, a subclass of application. So really, you just tell the surface to show charts, and it will create that, load it, run it in this surface that you have in your forms page. So this here, it's an application in start. It creates a scene. It subscribes to input. It creates a scene, octree, creates a plane, a camera, lights, and then creates a grid of plot items. And these are using a custom component here, which is called bar. So this, when it's attached to the node, it then creates another node that it controls. So these actually have a lot of the logic of what makes an actual bar behave like a bar. So I'm going to just run this, and we'll see what this looks like. There we go. So this is an Urho surface. You can actually click on it. It's using the input event to detect those. If I go and look at that, we have the, so when I click, it runs array into the screen to look at what's directly underneath that, and then calls code on that node to tell it to act like it's been selected. So this is a very sort of self-contained, encapsulated control that we have here, and yet these are forms controls here, which are also controlling our scene. Okay, and there's a bunch of other really great examples. Unfortunately, I don't have time to cover them all now. There are some really impressive scenes I can send you links to, because it is actually it's a very good renderer. Like, this is the kind of thing that would take you years to write yourself. There's a whole bunch of resources on learning more. We have a forum. We have some pretty good docs, a lot of great samples, and of course, Urho 3D has a lot of information about things that we don't cover in our docs in so much detail, like the material format and the rendering pipeline, and so on. If you're interested in learning more about the kinds of fundamental principles behind how game engines are designed, I recommend the Game Engine Architecture book. It's very good. Yeah, so any questions?
Yes, quite a few. So, like I said, I didn't want to interrupt while you're on a flow. I was leaving some of these to the end, but we have definitely some questions. So thank you, everyone, for all the questions. And I hope a lot of them were answered during the presentation, but we can go through some now. So going back to the first one that we talked about a little while ago, Ryan was asking, are there any use cases for using this for location-aware models? And we got a little bit more information. So his example is something like modeling a floor plan and then using the geo-coordinates to walk through a building. So with the app in hand, you'd load separate models to look around and see a building in different layouts, like for an architect showing a client different options for a building, things like that. Is this something that UrhoSharp could do?
Yeah, you could do that for sure. I definitely recommend checking out our HoloLens samples, because those do show that placing models into real space.
Can you go back to the links real quick? Just let everyone see that.
Yeah.
There. Okay.
Yeah. So you'll find that in the samples repository. Actually, I have that in. There we go. I have a web browser open with that. So that's what the HoloLens example looks like. Super cool. And there's a bunch of it.
Is there an actual video for that too? Did I see Miguel posted something that was UrhoSharp on the HoloLens that was a bowling game or something yesterday?
Yeah. There's a bunch of. I'm not sure what the latest ones are. This is actually under active development right now. But yeah, all that code is available. Like right here, there's a lot of helper code that lets you understand how that all fits together.
Great. Okay, so if you can show those links again, we'll let everybody copy those down. I'll put together a document that we'll have on the Xamarin University website, so it'll have all those links as well. You can go back in a couple days. We'll get this.
Yep.
Another question is, can I also build a 3D model using vectors, not static or model-defined objects?
You mean create the mesh directly from code, from just the points and from the vertices?
I don't know. So, Alan, if you can give us a little bit more context for that one, using a 3D model using vectors, we'll come right back to that. So, another question is collision detected.
I think I saw. Yeah. Yes, you can.
Oh, okay.
Yeah, I'm not 100% sure that's available from C#. It's definitely available in the underlying engine. I'm pretty sure it's available in C#.
So it says,
that's how the HoloLens demo, I think, is creating the geometry for the room.
Okay, he says yes. Just create the model directly.
Yeah.
Okay. So the next question is collision detection enabled in 2D and 3D?
Yes. Yep. Yeah. So there are actually two physics engines. There's a box 2D engine for 2D and the bullet engine for 3D. So you do have both of those available.
All right. Can you do a Google Cardboard app? That's an interesting question. To be able to do 3D?
I don't think we have any samples of that, but I don't see why it wouldn't be possible.
Right, because you're just showing some 3D on the screen, I would assume.
Yeah, well, there's additional code to do the projection of multiple views with the separation and the distortion and so on.
Mm-hmm.
So you might need to go into the native layer to get that hooked up. But it would definitely be possible to do that. It just might take a little bit of work.
All right. And let's see.
Oh, I would actually think HoloLens would actually be a good example for that, because that is kind of exactly the same problem, the multiple viewports to create the 3D view.
Right. That would probably be a good mapping of ideas there. So is there dynamic vector drawing? So this goes back to Alan's question.
Again, I'm not entirely sure what's meant by that.
All right, so we'll see, Alan, if you can give us some more information on what you mean by dynamic vector drawing. Another question, what's the benefit of having your resources in a shared project versus the PCL?
You can't put them in a PCL because the PCL just creates an assembly. It won't create a directory full of resources. Well, I guess it technically could if you had them all compiled to the output directory. Then you had a wildcard include into into your actual platform-specific projects. Yeah, there are. I would do the shared project approach just because I'm very familiar with MS builds, so I tend to end up writing all sorts of custom MS builds in my projects. And it just seems easier to manage that way to me. So you can't embed them in the PCL. You would still have to do some work to set up via a PCL because you would have to then get the files transferred across. Longer term, I've been working on something called the Xamarin Content Pipeline, which is inspired by the XNA content pipeline. And the advantage of having the files included in each of the actual platform projects means that you can actually optimize them for that platform at build time. So, for example, for a texture, you could have a single source file, a PNG file, defined in your shared project, and then the code that takes that item and actually embeds it in the app could do things like compile it for into a specific GPU format for Android or for iOS.
Great. All right, let's see. What's the next question? Where to go? All right. So in the demos, are there demos of using charts in the samples, or do we have any samples of actually using charts, chart making?
That form sample is in the samples. Yes.
Okay. So good. And do you know of any flagship apps in the stores that are using UrhoSharp?
No, not currently.
All right. Yeah, how about any that use just Urho? Do you know of any? There's got to be some that.
No, I believe there's been one game published on Steam that uses Urho, but it wasn't particularly well received, unfortunately. The thing is, like, in general, people writing games do often end up going with something like Unity or Unreal Engine because they're just they have hundreds of man-years of resources have been poured into making them very, very capable and polished, and they have fancy scene editors and all sorts of stuff like that. The advantage of Urho is that you have full source, top to bottom. It's very lightweight. It's very programmer friendly. You can do everything in code. You don't have to use an editor to put things together. Now that's kind of, some people see that as a pro, some people see that as a con. Like, some people, when they're writing their UI like a drag and drop designer, some people like to write it in code. Yeah, and also because it's open source, if you want to, it's very customizable.
So that actually
there are, well, but yeah, if you're writing a game, like a very big, serious game, and you had artists and so on, you would probably end up going for one of the big game engines. It would be expensive, but they would give you a lot of things that you don't get with Urho.
So that leads me to my next question. What's the licensing like for Urho and UrhoSharp?
MIT license.
So just completely free, open source. Anybody can use it.
Yeah. Yep. I'm not.
Awesome.
I'm not 100%. I would need to. I'm pretty sure. Urho's MIT. It might be Apache or BSD or something. I'm not 100% sure on that, but the bindings are definitely MIT license.
Yeah. So I'm looking at the Urho 3D page right now, and it is MIT license. So.
Okay.
Another question, is there a special plugin or a special mode to target HoloLens? And how is the background excluded from drawing when you're doing that?
There is a NuGet that takes care of a lot of the integration for you. I just switched back to the samples page. So there's the UrhoSharp package. So I'm not familiar with how it works in detail, but I would assume it simply doesn't render the background. It just renders the models.
Yeah, so whatever you decide to put on the screen is what it's going to put there, right?
Yeah, and if you don't have a background, then it's not going to necessarily have to render that.
Right. All right. And so then back to Alan's question of, is there any dynamic vector drawing? So more information, he says, a good example is using Urho to display a 3D model as a user's creating the model. Input system displaying the 3D display as they're creating and altering the model. A situation where the model isn't static, but it's changing based on user input data. So something that isn't just a static 3D model. Can you draw that?
I'm not sure of that offhand. I'm pretty sure it must be possible, even if it came down to just like destroying and recreating the mesh from the new mesh data. But yeah, I don't know of an example of that. But I'm sure it must be possible.
Okay, we can look that up. Yeah, so he says that's good. I'll do some research. So fantastic. So that is all of our questions. Thank you so much for all the time. I hope this is helpful to everyone as you're exploring 3D and exploring 2D and maybe getting into games and things like that, or charts, however you can apply this to your mobile applications. So thank you, Mikayla. Really appreciate that.